Hello, my name is Brian Rafferty, and today I will be continuing my discussion on Geographic Information Systems, or GIS for short. Today we will be going in depth on spatial databases, and I will be showing you a demo on how to create one for yourself. So, what will I be covering? I'll first be telling you what a spatial database is. I'll then go into what makes them unique. Next, I'll cover all the software requirements to get started. And then lastly, I'll actually show you a little demo. So what are spatial databases? Think of them as something that builds upon the foundation that SQL started. So a classic SQL database includes statements for comparing and contrasting data using joins, select, where, statements like that. And you can also insert into tables, you can delete from tables, you can purge tables entirely. Spatial databases can do all of these things, but then they also include three twists. They include spatial data columns, they include metadata, and they include spatial indexes. Now let's get into what those three things are. So spatial data columns are what are known as object columns, except they contain special information that's recognizable by the server. So you see in the picture in the middle, you create the table called baseball, and then at the bottom, the final index is shape SDO geometry. And so SDO geometry is the object that represents the spatial data column. And if you look in the picture on the bottom left, entry there is the pitching mound, and its SDO geometry contents within its object is that it's a two-dimensional polygon. It contains null values for both the SRID and the point type. It's SDO LM info array. This is all the information about the shape of the object and whether or not it has objects within it. So 1003 represents that it's an external object, so there's nothing on the outside of it. And the 3 represents that it is a rectangle. And rectangles are special because if you look at the SDO ordinate array, you only have two coordinate pairs. It's because rectangles are represented with what are known as MBRs, minimum bounding rectangles. And all you need is the bottom left coordinate pair, which was in this case is 10, 3.75. And then you need the upper right coordinate pair, which is 10.25, 3.85. And then let's get into the metadata. So look at the picture on the right. Insert into user SDO geom metadata. Now this entire entry is the metadata that includes information on the coordinate systems being used and the dimensions. So it basically represents all of the back-end information that changes the way that the user can see the objects that they create using the spatial data columns. So in this example, the baseball table is represented using a 20 by 20 grid, and that's done using the SDO dimension array. And these are completely customizable. You can change it to whatever dimensions you want. And then the bottom of this same photo on the right is the spatial index. These spatial indexes are how the data tables are actually being stored on the back end. These are either stored using linear quad trees or R trees. And R trees are the default. They're a lot less overhead by the back end of the computer. And if you want to know some interesting information on R trees, you can think of them like binary search trees, but for spatial data. So any object contained within an object on a picture is a child of the outer object, which is the parent in an R tree. You can look up pictures of R trees online. They're actually very handy and also very interesting if you want to take a look at them. Next is the software requirements. So what do you need before you can actually get started with the spatial database? You need Java Development Kit. I have, I believe, Java JDK 8. Next, you need the Oracle 11G, which is a database suite. This includes SQL, it includes all of the connections between the Java server and the Oracle database. And lastly is Map Viewer, which is a specific Java program that you can download. It includes all the files required in order to view your Oracle database using what's known as JView, which is a Java runtime environment. So let's look at how you can create one for yourself. So this spatial database using Java and Map Viewer is only ran on PC. So you're going to need to download VirtualBox if you have Mac. And then I wanted to show you the spatial table that we're going to add into our SQL. So here we create our table, create table spatial demo. Very simple, we keep it just like the example before with baseball. All we need is an ID, a name, and a shape. The shape is of course SDO geometry. And then we're going to add some shapes to it. The first one we'll add is a rectangle. 1003 indicating there's nothing inside of it, or it's the outer shape, and 3 represents rectangle, and then we have the bottom left coordinates and the upper right. Next we have circle. These are exactly the same as a rectangle, except you notice rectangle had 3, circle has 4. They're just special indexes representing the different shapes. Anyway, circle, instead of having an MBR, circle has to have 3 points. You have to pick 2 points directly across from each other on the circle, and you need to pick a third point representing the radius. So you have the diameter and the radius listed. So you do 10,9 and its diameter point 10,13, and the radius, which is 90 degrees right between the two of them, 12,11. And lastly, I wanted to show you guys a polygon. Polygons are unique because you have to actually list out every single coordinate located on the polygon, and if you notice, the first coordinate pair has to match the last coordinate pair because these polygons have to be enclosed. You can't leave it just as a line. And then next is the metadata column. We're going to also do a 20 by 20 grid, just as in the baseball demo before. And then here is our spatial index in order to add it into the R tree. So, just want to show you guys my SQL table. So here's SQL, and I am going to describe spatial demo. So it shows the 3 columns. And then we can do like a select star from spatial demo. And that shows all 3 of the shapes inside. I've already taken the time to copy paste the code into SQL. And then next, we start up Map Viewer. Now when Map Viewer is running, you'll see all of this information saying, I did all these checks and the configurations, everything's cool. Okay, so then the server started up. You can go on your local host. This is the URL right here, localhost 888/mapviewer. And then you can click on demos. Then you can click JView. And I've already opened it up previously, and voila, you can see the three shapes from the demo, including the rectangle, the circle, and the polygon, which we enclosed. And if you want to do some more queries, let me slowly scroll down. Okay, here we go. Let's do select star from spatial demo where ID equals 1. And let's put it as a color. Let's say green. Okay. Submit. All right. So now if you remember from our table before, the rectangle had ID 1. And now we just did some spatial analysis on our map. The rectangle is now filled with green. Pretty cool. All right. So now that you know how it's done, you first create your SQL table. You add your spatial columns containing the shape info and the coordinates. You next add your metadata, which will control how large of a pane you want to view. In our case, it was 20 by 20. And then third, you decide how it's going to be stored, whether you want to do it in a linear quad tree or in an R tree. Here are some references. If you want to learn more information about how to do everything, you can go on Professor Ekberg's website. I have it listed there as edorist.sdsu.edu, and he has some source information on how to do Map Viewer and how to get it running. And then I also included the Java docs for Oracle and how to do SDO geometry. Thank you for watching. Again, my name is Brian Rafferty. If you want to connect with me on LinkedIn, there's the URL there. Hope you have a great day.